Now let's try a third example. In this example, we're not only going to find the empirical formula, we're also going to find its molecular formula. So we have a 2.5 gram sample, and it's found to have carbon, hydrogen and oxygen in it. So I'm just going to start my table: carbon, hydrogen and oxygen. Now our first step is to find its mass. So we've been told that we have 60% carbon, which means it's 60 grams out of 100. 8% hydrogen, which means it's 8 grams out of 100. So the mass of oxygen must equal 100 minus 60 minus 8, which comes out to 32 grams. So 32% or 32 grams out of 100. Now, our next step is to find the moles. Now, remember, number of moles is equal to a mass over a formula mass. So, the formula mass of carbon is 12.01. Formula mass of hydrogen is 1.008. And the formula mass of oxygen is 16. So, we can now find our moles. And this comes out to 4.9958, which I'm storing in my calculator. 7.9365, and exactly 2. Now, to get the simplest ratio, we always divide by the smallest number, which in this case is 2. So the simplest ratio is going to be 2.5, 4, and 1. Now, 0.5 causes me a problem. It's not a simple whole number ratio. So we're going to times everything out by 2, so it comes out to 5, 8, and 2. So the empirical formula is C5H8O2. Now the next step is to find its molecular formula. Now we've been told it has a mass of 200 grams. So we do a ratio, which is going to be equal to the molecular formula over the empirical formula mass. So the molecular formula we've been told is 200. So now we need to go through and add up the empirical formula. So we've got 5 times 12.01, add 8 times 1.008, add 2 times 16, which comes out to 100.114. So this gives us a number of about 2. So now to work out the molecular formula then, it will be equal to 2 times 5, so C10, 2 times 8, which is H16, 2 times 2, O4.